Hi folks, welcome to this big stream. Um, we're going to be looking at some of the migration related workflows with Hasura. What that means is that when you are working on Heroku, you want to move to a production ready deployment, which could be on DigitalOcean or on somewhere else, or you want to replicate your Hasura instances, the configuration of your Hasura instances. You want to copy the tables tracked, or you want to replicate the event triggers, remote schemas, etc. on a different Hasura instance. All of which are covered in the all of them are covered in the migrations workflow with Hasura. You can also choose to track your Postgres schema changes with Hasura. Whenever you use the Hasura console using the CLI, the console will be able to generate and log the SQL statement that you execute, and later you can apply them on a different instance as well. So we'll get started with a simple use case where you have been working on Heroku and you would want to move to something like DigitalOcean, and we will continue to build upon that. So in case you have any questions, feel free to ask on the chat. I am monitoring the chat window as well. So let's get started. First, I'm going to create a Hasura instance on Heroku along with the Postgres database. So I'll click the deploy to Heroku button, and I will be prompted to create a new app on Heroku. So while that's happening, let me choose a name. I will call it Hasura Migrations. So the app is getting deployed. So in between, let me introduce myself. I am Shahid. Most of you might know me from Discord. I am an engineer at Hasura. I mostly work on the migration related workflows with Hasura. So the app has been deployed. Let's head to the console, and we'll get the console now. So while you are starting with Hasura, or when you are evaluating Hasura, you might be using the you most definitely be using the console to create and create tables, try out GraphQL queries, and etc. Right? So I'm going to the data tab. I'm going to create a table. My table name is, I'm going to use a sample article author schema here. My first table is called authors. Author has an ID and a name, which is text, and I'm choosing ID as the primary key, and I'm creating this table. Next, I have another table called articles. Article has an ID. Article also has an author ID, the author who wrote the article, which will be an integer. Then there is a title, which is text, and then there is body, which is again text. So I'm choosing ID as primary key again, and I'm creating this table. So now I have two tables, and I can add a foreign key for the author ID column. I will choose author ID as a foreign key. I'm leaving these settings as default. Now as soon as I have the foreign key, if I go to the relationships tab, I can see the relationships being suggested here. Same will be there on the authors table also. There are some relationships being suggested here, right? Instead, I'm going to go to the data tab, where it's asking me that two relationships are there based on the foreign keys. I'm going to click track all and track all of these relationships. So now I have a article author schema set up, and I'm going to go and insert some data. First, I'll create an author. I'll put my name. So I'm going to create my name. I'm an author, and then I'm going to put another name called let's say Tanmay. And based now, if we look at the tables, we have one ID1 Shahid, ID2 Tanmay. Now if you go to the articles table, and let me create one article for me. I'm gonna create, I wrote the migrations documentations, so I'm gonna create one article based on that. And then I'm gonna insert another article. So Tanmay wrote the auth docs. So now we have two articles as well, and they are linked with the authors. Now if you go to the GraphQL schema, we can see in the Explorer we can see how the schema is appearing. So let's take a look at authors, the name, articles, and the titles. So let's make a query for this. So there are two authors, and both of them have one article each. So this is a typical data model where you have a couple of tables, you have foreign keys and relationship across them. Now let's say you have let's create an event trigger. So we'll just so that we cover all the aspects of the Hasura GraphQL engine. So we have an event trigger, and let's call it let's do one thing. I have the authors table, and let me just call it dummy trigger, and it's on the authors table. And whenever okay, let me call it, okay, let me do that. Whenever an insert happens on the author table, this webhook is called, this is the dummy webhook, http bin.org/post. So this event trigger gets added. Now we have an event trigger here. Let's also add a remote schema. So there's one remote schema that I always use, thanks to the author, https graphql pokemon.now.sh. So we'll add this Pokemon remote schema. Now if you look at our GraphQL schema, we can see we have Pokemons as well. Pokemon first 10, give me what? Give me the names. This will give me 10 Pokemon names. Awesome. So now you have been building your application. You have some tables set up, you have a remote schema, you have an event trigger. Now let's take a look at how Hasura stores all this information. So what Hasura does is, it is going to store all this information in the Postgres schema called HTB catalog. So these are all the things that are implementation details. You don't need to worry about all this. One better way to look at this is by going to the settings menu, and you will see that metadata related operations are here. So if you export the metadata, you will be able to get all this information as a JSON file. So I have downloaded the metadata now. So this is the metadata. I'm gonna copy this. Wait, what I'm gonna do is, so I'm gonna run it through JQ just to format it. So if you look at this, what is better is, I'm gonna convert it into YAML. So if you look at this metadata, we can see various top level keys and then the object definitions under them, right? So there is remote schema, and the configuration required for remote schema is present here. And then there is a tables key, and each table will have an entry in this array here. For example, this is the authors table, and the permissions on the table is given here, and the event triggers on the table is given, the relationships on the table is given. Every property of the table is listed in this metadata.json or YAML file. So similarly, we find an entry for the articles table. We haven't defined any permission, so that those keys are empty. We have defined an object relationship, so we can find the relationships here. So let's take a look at what happens if we add permission entry. For example, let's go to the authors table, add a new role called user, and for select permission I'm going to say ID should match with the X Hasura user ID role, and you are allowed to select all columns. So I save this permission, and if I go and export the metadata now, if I click the export metadata button and I will save the file, it's metadata2.json, and let's look at the metadata2.json and look at the YAML, or let's just look at the JSON itself, and we will see that for the authors table there is an entry for the select permission, right? So role, user, the columns that are allowed are ID and name, and the filter operation is this ID equals X Hasura user ID. So every single thing about your Hasura instance can be declaratively exported as this metadata file. Now let's say I have another Hasura instance where I want to I have a similar Postgres schema, article author schema, and I want to import this permissions and everything onto that remote schemas event triggers. I can just directly import this metadata there. So let's just take a look at that. So this article author, ID, name, articles, and title, body. So what I'm going to do is I'm going to start an instance of Hasura GraphQL engine locally. So I have this Docker Compose file here, which I have taken from the default Hasura documentation. And what this will do is, if I do Docker Compose up -d, it's going to start Hasura. Okay, something is wrong. Let me take a look at the Docker Compose. Oops, this is wrong. Postgres. So this is going to start Hasura locally, just like we created Hasura on Heroku. We are creating a Hasura instance on my local machine. So if you look at this, Hasura is running and it's listening on port 8080. So if I go to localhost 8080, I have a brand new Hasura instance, right? I have a brand new Hasura instance. So there is nothing here, no tables, nothing. And let's say my DB admin will always provision the tables and foreign keys, etc. required for this, and I am gonna do that by using PSQL. So I just need to get the SQL for it. I'm just gonna grab it from a repo. I have the SQL for this article author schema. So what I'm going to do is I'm going to create vim article author.sql. So I have this SQL here, and let's say your DB admin or your Postgres schema is taken care by a different tool, and that tool is always going to create the tables for you. I'm gonna apply this SQL on the Hasura instance. So I'm gonna say docker exec the Postgres container PSQL -u Postgres pass this file to std in. So let's see if that worked. Okay, it definitely did not work. I am doing this wrong. Okay, so let's see, what did we do wrong here? Maybe docker exec is not working the way it is supposed to. So let me add these two. Okay, it's not a tty. Okay, let me do this. Docker cp article I'm gonna copy this file into that particular container /schema.sql and docker exec into the container. If your Postgres is exposed outside, you can just directly use psql and do it. I'm gonna exec into the Postgres container and do it. -it bash. So now I'm gonna do psql -u postgres -f/schema.sql. So two tables have been created, and if you go to the Hasura console, we see that two tables are there, but they are not tracked, right? And we don't have any remote schema. There are no events. So, but on our Heroku app here, we have these tables tracked. We have a remote schema. We have an event trigger defined. So I'm gonna export the metadata, save it. This time it's saved as metadata 3.json, and I'm gonna go to the local Hasura instance here and import the metadata. So I'm gonna say recent metadata 3.json. So this metadata is being imported, and metadata has been imported successfully. Now if I go to the data tab, I can see my tables are tracked, relationships are present, the permissions are present, my remote schema is there, my event triggers are there. So everything from your Hasura instance on Heroku is replicated here on this locally running Hasura instance. So this is under the assumption that your Postgres schema is handled separately, and that is always present. The tables on the underlying Postgres instance are always present. If they are not, what's going to happen is that in the metadata file, Hasura is going to say that there is a table called authors that is tracked, and it's going to try to find this table in Postgres, and it will not be able to find the table and will throw an error. So now let's take a look at a scenario where the Postgres schema is also taken care by Hasura. That means even the Postgres related schema files, etc., will be taken care by Hasura. Okay, so let's take a look at that, and for that I'm gonna take you to the documentation. So all of these use cases or most of the use cases are documented in our migrations and metadata page. So it gives you a small introduction on what migration is, what is metadata, and when you should be using it, and it kind of broadly divides the use cases into two based on what setup you have already. One, you are already using a migration tool for Postgres schema. That is what I had just shown you. And in this scenario, what you will do is you will go to the console, you will export the metadata after you have tracked all the tables, views, and created a relationship, etc. And then you will go to the other Hasura instance and just import that metadata, right? But this can be pretty cumbersome if you are doing it from a CI/CD, or if you want to automate it. Well, you are in luck. We also have an API to do the same, right? So there's a metadata API with which you can execute the same action that the console is doing. So if you look at the console network tab, uh, and when you export the metadata, you can see a request being made. So if I cancel this download, and if you look at the request is being made to an endpoint called v1/query, and the parameters are type export metadata and args are null, and it will give you the metadata in response. So this is exactly what is documented here in the metadata API page, where export metadata is a post request to v1 query, and you will be able to get the metadata. And similarly, you can do a restore replace metadata, where you send the metadata object that you received earlier as the post body in this argument to the same endpoint. So if you look at the API equivalent for that using curl, you can do curl-d, catch the metadata file into the args object and post it to the v1 query endpoint. Let's just try this out just to see, get a feel for it. So if I want to do the same thing, I had the file was in downloads metadata 3.json, right? So if I execute this, the instance is gonna replace the metadata and give me a message success. So everything you do on the console, each and every action on the console is available as an API. So Hasura as an extensive metadata API. So if you go to the API reference page, we have documented all the APIs, and if you go to the schema metadata endpoint, you will be able to see all the endpoints, all the types of queries that are available. There are APIs available to track a table, track a function, create an object relationship, array relationship, create, update, delete permissions, metadata, and run SQL. You can use this to run arbitrary SQL queries on the Postgres instance. All of these APIs are admin only. That means you need to be the admin with the admin secret to execute these APIs. So we have the migrations and metadata. So this is what you do with if your Postgres schema is managed by a different tool. Now let's say you are not using any tool for managing a Postgres schema. What you will do is you will use the Hasura CLI along to get the schema or to get the actions that you execute on the console as files and save them in a folder, and you can just commit that repo and all. So in this scenario also, so the Hasura CLI will launch the console, and you will be able to track everything you do on the console. But here also there are two scenarios where you have already set up everything, and another scenario in which you are starting from scratch, an empty database and a fresh Hasura instance. We'll take a look at the first scenario where we already have a database set up, which is what we have on Heroku. We have this database set up on Heroku. We have some data in it. We have a schema there, and we will take a look at how that can be done. So what my intention here is, I want to move from Heroku to DigitalOcean. So to do that, I am going to go to the DigitalOcean marketplace, or I can just go to the website. So I will go and launch, the DigitalOcean thing. I will say quick start work. So this will take me to the DigitalOcean marketplace for the Hasura GraphQL engine. So you will be able to see a couple of instructions and all here. So I'm going to create a Hasura GraphQL engine droplet. It's enough. the $5 instance is absolutely enough for Hasura. It'll run fine on that. So I'm going to choose the $5 instance. I'm going to choose Bangalore. Let's say enable monitoring. I'm going to add my public key as well. So where am I? Yep. So I'm going to call it Hasura streams. So while the droplet is getting created, let's take a look at the other requirements for this workflow. So the first step in this workflow is to disable console on the server. So by default, the server serves the console. When you go to the server endpoint, like what you saw on the Heroku app, you get a console, right? And you get the similar thing by using the Docker image also. So since this console is not running out of any persistent file system or things like that, it is quite difficult for this console to log the actions it does to generate SQL files or the migration files that are required. Because of that, we have created a CLI tool with which you can run console connected to a GraphQL engine instance. And since the CLI is running on your machine in your local instance, a complete file system is available. It can write files based on what the console is doing. But if you are using the console from CLI, somebody else will go on use the console on the server, and let's say they create a new table and you don't have the required files for that particular action, there are gonna be some inconsistencies. So what we recommend is that you disable the console on server entirely and you solely depend on the console for console served by the CLI. So we are going to do this on both Heroku and our new DigitalOcean instance. So first let's disable console on the Heroku app. So the console is now working fine. What we're going to do is we're going to go to the settings and reveal the config vars and add a new key called Hasura GraphQL enable console as false. So this will disable console on the Heroku app. So if I go and refresh now, it will say, oops, it's still working. Let the dyno restart. Okay, am I in the right application? Yep, I'm in the right application. Hasura GraphQL typos enable console. Let me look at the documentation. Hasura, I'll copy paste this. That's right. False is right. Maybe let me just restart all dyno. Okay, restarted. Yeah, console is gone. So it's just the dyno had to be restarted after the change was made. So we have restarted the dyno. The console has been disabled. Let's take a look at so we'll not be able to load the console anymore. So we have completed the step 0, which is disabling console on the server. Let's take a look at the next step. The next step is installing the Hasura CLI. So for the migration workflow where the Postgres schema is also tracked, you need to install the Hasura CLI, using which you will do a lot of migration related commands. So I'm going to choose Linux. So I'm going to copy this command and paste it in my terminal. So this is going to download the CLI. It's telling me that you already have the CLI, but let it overwrite it. So it's downloading the CLI. It's asking for my password. And we have the CLI installed. So if I do Hasura Hasura, it's gonna print out the help for the CLI. We have a couple of commands here, we'll come to them. So we have completed step 1 also. Now let's take a look at step 2. Step 2 is setting up a project directory, right? So you need to initialize a directory with the endpoint for your GraphQL application. So I'm going to copy this command. I'm going to switch to a directory, and I'm going to create this directory. Execute this command. I'm going to call it, the project is called Hasura Streams, and the endpoint is let me take the endpoint, and the endpoint is okay. It looks like there is some flicker happening with the screen. This is the endpoint. Endpoint is, and it created the directory. Oops, I think I forgot to unmute myself. Really sorry about that. So what we did is, we created the directory. We have two files in the directory, which is created by the CLI config.yaml and migrations, and the endpoint that we gave as a flag has appeared in the config file, and we are creating the migration files by kind of introspecting the server. And this is all possible because of a combination of what the CLI does and a couple of APIs that are there on the server. This is particularly an API that lets you execute pgdump on the server, and that is how Hasura is able to get the Postgres schema from server. So let's take a look at what are the files created. We have a migration name called init, and the version is this. This is usually the timestamp. So let's take a look at the migration directory now. So we have two files created, one SQL and one YAML file. Let's take a look at the SQL file. It is a schema for creating the articles and the author table, right? So article, author, table, and the foreign keys and the primary key sequences are all here. Let's take a look at the next file. and this SQL file is extracted from the server um, by looking at what is there in the Postgres at that point. And this is also a little bit cleaned up to remove certain Postgres friend matter and remove certain things like comments and couple of other unnecessary stuff. Now if you look at the YAML file, the YAML file is exactly what the metadata export command gave us. What we got when we did metadata export on the console. It's using the same API, it's executing the metadata export API, and it's getting everything and saving it on the disk. So we have our trigger here, we have our Pokemon remote schema, we have our permission rule, we have our relationships, and everything is present here. The next step is to mark this migration as applied on the current server. We have created a migration, but we haven't there's a concept of what migration is applied and not applied. If you execute Hasura migrate status, you will be able to see that these migrations are present on the file system that is source, and these migrations are present on the server. Technically this migration is present on the server because we took it from the server, but since it is not applied on the server as a migration, the server doesn't yet know that this migration was applied, right? For that we need to mark it as applied. For this we will execute another command called Hasura migrate apply the particular version, but we'll skip the execution for it. So skip execution means that SQL and YAML will not be executed. Instead they will just be marked as applied. So I'll take this version and I will mark them as applied. So this migration will now be marked as applied. We will check the status again to see what the current status say. So we'll execute status again and it will show that both are present, right? Okay, let's move on to the next step. The next step says now use the console from CLI. So we have already disabled the console on server. We'll not be able to see the server console. So we need to be able to use console. For that, use the console from the server, from the CLI. So if I execute Hasura console, this will now open up console served by the CLI. It is the exact same console that is served by the server. The URL is the same. You can browse the same data, same articles, authors, everything is there, remote schemas, events, everything is exactly the same. But the big difference here is that, let's say I'm gonna go to the articles table, I'm gonna create another permission, or I'm going to create a permission for the user role on the articles table with the check author of ID is equal to x Hasura user ID and the columns, all the columns. And if I save this permission, it's going to take a tiny little bit of time. It's going to take it some time because it is going to contact the Heroku app and save everything, right? So the permissions are updated. And if we look back at our migration files, we can see that a new migration is created, right? So let's take a look at this migration. So this migration says create select permission on this table for this role with this configuration. Now if you take a look at the down.yaml for it, it says drop select permission for this table for this role. So whatever we did on the console created these two files which said created these two files, where one is the up action, one is the down action. So let's take a look at the migration status now. Hasura migration status. Oops, let's migrate. Hasura migrate status. So it will show that we have two migrations and both of them are applied. So now let's replicate. I want to put this entire configuration including the schema onto the DigitalOcean instance. Let's see how I do that. First I will go to the DigitalOcean instance. It is ready. I will SSH to it and disable the console. So I'm going to say SSH root at this. I'm going to say yes, and I'm gonna do cd etc/hasura vim docker compose, and I'm gonna set an admin secret as well. Super secret key. So I'm gonna change this enable console to false. Now let's take a look at the console right now. This is the IP. If I go to this IP, I'm able to see the console. There is nothing here. It's empty. No remote schema, no events, no data. And I will apply this configuration: docker compose up -d, the admin secret, and the console disabling. So the server will restart, the GraphQL engine container will restart, and let's quit from there, and let's take a look at the console now. It's gone, right? This IP is no longer serving the console. So now what I want to do is, I have the migrations here and I want it to be applied on the new server. So I execute Hasura migrate apply --endpoint. My endpoint is the IP address. That's where the GraphQL engine is listening. I will say HTTP this IP address. This could be your production server domain IP, whatever, and I'm gonna say apply, but it says access is denied because admin secret is required. So I'm gonna say admin secret. Admin secret is super secret key. So I'm going to apply the migration, and it is going to take all the SQL, YAML, all the API calls over there and apply this over that particular instance. Now I have disabled the console there, so I can open the console on the new instance by executing the same command, but removing this to changing this to console. So when this console opens, we'll be able to see the tables etc created. So I have the tables here, I have remote schema here, I have events here, and if you look at the GraphQL, oops, there's something wrong. This is the old console. So okay, so we have another console running here. Let me just stop that and then we will run this one. So we have the console is connected to the new GraphQL server Hasura instance, and we have all the data and everything, all the tables, remote schema, and events over there. Now the data that we had earlier is not present here, and migrating data is super easy as migrating your as it's a Postgres tool. So what you do is you execute pg dump on the source server, and then you use pg restore and restore the data. It is a typical Postgres workflow which you can continue to use. Hasura does not come in the way. So we took a look at how we can migrate from one instance to another. Now let's say you're working on a dev staging production environment, right? So you have set up migrations, everything is working, all migrations are being tracked, and let's say you opened the console. The console is there, you created a new table. So this console is on your prod instance. You can look at the IP and understand that. And then let's say Heroku is your dev instance. So what you have, if Heroku is your dev instance, Hasura console by default is going to take whatever is present in config.yaml. The Heroku app is in config.yaml. So if I do Hasura console, it is going to open the Heroku the Heroku console connected to Heroku app. And let's say I created a new table over there. Let's say a new item was added for managing the let's say we are decided to have tags for articles. So I have a tag ID which is integer argument, and a tag name which is text. Oops, this is a text, and then I'm gonna model it as a many to many relation. So I have tags, and then I have article tags table, which will be a through table for storing the tags. So now I'm going to create the article tags, where I have article ID an integer and the tag ID another integer. Primary key, a combination of both are the primary key, and both are foreign keys. I'm gonna add a foreign key to articles. Article ID is articles ID. Add another foreign key to tags. Tag ID is this. Oops. So now I'm gonna create this table. So with the foreign keys, the table is created. So I've created 2 new tables, and I've created a bunch of foreign keys, and I can also add the suggested relationships, right? I'll just add them from here, or I'm just adding all the relationships. So now we have made a bunch of changes on our Heroku app, which is kind of our dev instance, and now we want to get all these changes on our production instance. We have tested it, we have built a UI around it. We want to get all these changes on our production instance. So let's take a look at how we can do that. So we will close the console, and if we'll take a look at the migration status, it will say for the connected instance with the Heroku app, all are present. But if I use the endpoint and the admin secret and try to get the migrate status for my production instance, it's going to say that 3 migrations are not present, right? So all you have to do is use the same flags and do migrate apply. Now these changes are going to get applied on your on the other instance which is running on DigitalOcean. So let's say you're working on multiple people are collaborating, and they're all working on their own local instance. What they can do is have their own migration files generated for their own particular branch, and then you can merge those branches together into the master branch and deploy the master as your staging environment, and have a production branch separately, deploy it as your production environment. So you can commit all these migration files. So if our migrations have grown, we can commit all of them, and we can make sure that all of them are tracked and version controlled. So I can do a git init here and git status, git add dot, git commit -m, add migrations. So if you are working on a new feature, you can do git checkout -b feature 1, and you can have new migrations in this branch, and then submit a pull request to master, which will get reviewed and merged. And whenever everything is ready, the master branch can be merged into a prod branch, and you can have multiple feature branches. And since the migration versions are timestamps, it's highly unlikely that, and these are up to nanosecond precision, it's highly unlikely that two people have the same migrations. But even if that arises, it's like highly unlikely. Even if that happens, you can manually go and fix them by hand. It's quite easy to read these files. So one thing, if you might have noticed, is that if you look at the YAML files, it's an array. Every YAML file is an array of a combination of type and args. If you had noticed the documentation earlier, this is the metadata API. These are all metadata API calls. So if you look at the requests, each one of them, for example, the last one is a drop relationship. So if you look at drop relationship, where is it? Drop relationship, type and args, right? So these are all metadata API calls saved in a file, grouped together, and they represent a particular action. So if you want to write these files manually, we have documented that also properly. So if you have advanced use cases, you can also write the migration files manually. You can execute the migrate create command with a name. It will bootstrap the files for you, and then you can write each file where each file is a combination of API calls, a collection of API calls. So these API actions iteratively or incrementally builds your metadata, and you will be able to write them yourself, and you can apply them manually. So in case something went wrong and you want to revert a particular migration, so if I look at migrate status, if I look at the migration status, and my last one is what, track this migration was buggy, I want to revert it, I execute Hasura migrate, I need to check the help, Hasura migrate apply, Hasura migrate apply, I will say version hyphen type down. So this is going to apply the down migration for that particular version. What that means is the entire action will be reverted. So if I check the status now, that particular version will appear as not present on the database. So you can move around in your schema to a different point. You can even like apply number of down steps together. For example, if you use the down flag and say n number like 2, it will go back 2 steps. If you use the up flag and say 2, it will go up 2 steps. You can even individually revert a migration, you can individually apply a migration. All of these are possible. Check the help for the command to figure out other scenarios. So now a typical so let me mark that as applied. A typical situation thing that you will end up is that you have a lot of migration files, right? You have like 300-400 migration files depending on how big your project is. It's good to have this history so that you can go back and undo something later, but in a sense that if everything is all right, your app is deployed, and you want to uh, this is kind of a aesthetic issue, you can combine all these migrations together by taking a snapshot from the server again and getting rid of the current migration scenario, current migrations directory. So to do that, let me go to my master branch. To do that, what you can do is you can just uh, delete everything in the migrations directory. So I'm gonna delete all the migrations, and I can create a new init migration by looking at the server, what is there on the server right now. So what we are doing is that we are resetting our migration state, we are deleting everything that we have on our system, on our file system, on our project, and we are taking one server as a source of truth, because that is where we applied all these migrations, and dumping all of them into one single migration. So if we execute this is going to look at the server again, execute a migration metadata export, execute a pg dump for the schema, and it will create those files in the file system. Now this will cause one issue where we have all these migrations applied. The server thinks that if you look at the status now, we have created a new migration which is not marked as applied on the server. So we have a new migration here which is not there on the server, but we have all these migrations that are there on the server but not there on our local system because we just deleted them. So the reason why this is happening is that each entry here is saved in a table in Postgres. So we'll take a look at that. So if let's open console, each entry here is saved as a particular entry on a table. So the table is called star from hdb catalog dot schema migrations. So make sure this is not checked, otherwise it will save that also as a migration. So we see that there are versions which are saved on the database, right, which are marked as not dirty. So we just got rid of all these migrations from our local system. We just added a new migration. So what we can do is we can delete all of them. So what I will do is delete from hdb catalog.schema migrations where version not equal to last one, right? The one we created is 1557536. Which one is it? 1557356. No, 536. Yeah, this will not be there because it is not applied yet. So we can just delete all the migrations here. So I can just issue truncate table. So this is gonna kind of reset the migrations table. So if we come back and execute the status, we see that the migration status will be reset. We have one present on the source, but not that is not present on the server. So we are going to do the same skip execution with the version, and now we have brand new single migration which is a combination of all the other actions that we have executed. So let's take a look at what those migrations are. So if I look at the SQL file, we see we have article tags, articles, we have the authors table, we have all the tables here, right? So everything is here. So that's the idea. It's all combined and we'll be able to look at all of them. So we have the remote schema, we have the table, we have the permission rules and everything. So I think that's a wrap for today. I hope you were able to learn a couple of new tips and tricks about migrations, and we have a lot in the pipeline regarding migrations. This resetting migrations can be easily made a command. We have an issue open for that. If you're interested in contributing, it should be pretty straightforward. You can contribute to the CLI, which is written in Go. And that's a wrap for this week. I think there were some issues with the stream screen flickering. We will take a look at that once we put this out on YouTube. And join us for next week. Till then, bye bye. Good night.